Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Longest palindromic substring, Leetcode 5. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. In this problem, we are given a string S and we should return the longest palindromic substring within S. A substring of a string is defined as a sequence of consecutive characters within the string. For example, for this given string, BAB or ABA or BAD, all of them are sequence of consecutive characters. Hence, they are substring of given string S. And a palindrome is a string that reads the same backward as forward. And we have to return the longest palindromic substring. So, it can be either BAB or ABA here. And we can return any of them as the answer. Similarly, in example 2, substring BB is the longest palindrome, which we will return as the answer. Now, in terms of solution, one of the naive approach will be to generate every possible substring by running two nested loops. For example, first we will create the substring starting from B, so it will be B, BA, BAB, and so on. And similarly, we will repeat this process for each character, like starting from A, and so on, until we have considered substring for every character up to the end of the string. And for each substring, we will check if it is a palindrome or not. And throughout the iteration, we will keep track of the longest palindrome found so far as the answer. We have covered how to check if a string is palindrome on the channel. Please check out the I button and the description if you are interested in revisiting that explanation. Now, even though this approach works, the time complexity to generate all substrings will be O of n square, where n is the length of the input string, since we are running two nested loops. And furthermore, for each substring, we check if it is a palindrome or not, which takes O of k times, where k is the length of the substring, and in the worst case, k will be equal to n. Hence, the overall time complexity will be O of n cube, which is super high. So how should we improve on the brute force? One way to solve this problem will be to use dynamic programming, taking a Boolean DP matrix where DP of ij denotes whether a substring from j to I is a palindrome or not. So we run nested loop to fill in this DP table. And if at any point we find that a substring is a palindrome, we will track the length of that substring and the longest among them will be our answer. But in this video, I won't be covering DP approach, as there is even more cooler approach to solve this problem with similar time complexity, which we'll call expand around center. You will see why shortly. If you are interested in the DP based solution, please check out the code link in the description below. Now in the naive approach, we were creating substrings and then checking if they were palindromes. Generally, this involves putting two pointers on both ends of the string, and then for both pointers we check if the characters match. If they do, we move the pointers inwards, but if they don't, then the string is not a palindrome. For example, in this string, the characters B and D at the respective pointers don't match, so this string is not a palindrome. But if we add B instead of D, then the characters match and we move the pointers inward and continue this process until the left and right pointers meet. If we find no mismatch throughout the process, the string is a palindrome. And this is how we check if the left half is equal to the reverse right half. And for the odd length palindromes, we ignore the center character. But there is another way to check if a string is a palindrome, which is by checking from the center point and moving outwards. Say we are at this point, and if we expand from the center, we see character A on both sides. So the whole substring ABA is a palindrome, and this method, for example, gives the odd length palindrome. We'll explore even length palindrome shortly. So now let's put this into practice. Say we start with the iterator or a pointer pointing to the first character B. Now we try to grow or expand the palindrome around this index and track the longest palindrome. Expanding around B, there is nothing on the left to balance with the character on right. So the length of the palindrome with B as center will be just 1, containing the character B itself. Next we see character A and try to expand around it. To the left there is character B which matches the character on the right, which is also B. So we get a valid palindrome of length 3, which is BAB. Expanding further is not possible as there is no character on the left which can balance this A on the right. So the longest palindrome with A as the center will be BAB. Next, we move the pointer forward and come to character B and try to expand around it, where on the left we see character A which matches the character on the right, which is also A. So we can form a palindrome ABA of length 3, and expanding further, on the left we have character B and on the right we have character D, which mismatch, so we cannot form a palindrome, and so we can't expand further. And the longest palindrome we can form with this B as center is ABA of length 3. And continuing further with the remaining indices where we see elements A and D, we will find the palindromes of length 1 each, and in the end the longest palindrome we found with this process were of length 3, which can be either BAB or ABA, and they are all odd length palindromes. Now let's look at how we can form the even length palindromes. For the odd length palindromes, we expand around a single character. However, for the even length palindromes, we can grow around 2 characters. So if the characters at the 2 indices match, we can actually form a even length palindrome. And we continue expanding outward as long as characters around these 2 points match. So here, for example, this string is not a good example as it does not have any even length palindromes, since no 2 consecutive characters are the same. But if instead of this D, for example, we had character A here, then we will find the even length palindrome. Let's see how. So this time we would start with the pointers at the first 2 characters and compare those characters. Here, for example, B and A don't match. So we move the pointers forward for the next search. Now A and B don't match either. So again the 2 pointers move forward. And similarly, characters B and A don't match either. So the pointers continue to move forward. And finally, the pointers point to the same character A, allowing us to form an even length palindrome AA of length 2. Next, we try to expand further. But if we expand further, on the left we see character B, but on the right there is no character to balance it with. Thus, the expansion stops. At this point, we have reached the end of the string, so the iteration stops as well. Now, the longest palindrome, whether odd or even in length, turns out to be of length 3, with palindromes being BAB or ABA, and either of the longest palindromes can be returned as the answer. Now, the time complexity of this approach is O of n square, because we are going through each index in the string only once and try to make expansion around that center, which takes O of n time in the worst case, and hence the overall time complexity will be O of n square, and the space complexity will be O of 1 because we are using few pointers here and there. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on left and Python on right. First, let's initialize answer variable to store the longest palindrome found so far, initially equal to empty string. And let's also declare max length to keep track of its length, initially equal to 0. Now we will iterate through each index in the string, treating it as a potential center of a palindrome. And each iteration considers 2 cases for odd length and even length palindromes. First, let's expand for the odd length palindrome, where we call the function expand around center. This function takes in 2 starting pointers, left and right, along with the input string, and attempts to find the longest palindrome starting from the starting pointers. For the odd length palindrome, we start only with one index, so we will pass in the same value of I for both left and right starting pointers. And this helper function returns the longest palindrome with the character at index I at the center. And if the length of this palindrome is greater than the currently tracked maximum length, then we update answer to this palindrome and maximum length to its length as it becomes a new answer. Next, we expand for even length palindrome, where the growth happens around 2 characters. So we will call the helper function passing in left pointing to the current index and right pointing to the next index I plus 1. And if the length of this returned even palindrome is greater than the currently tracked maximum length, then we update answer to this palindrome and maximum length to its length as it becomes a new answer. And once the loop completes, we have checked all the possible centers. Hence, we will return the answer, which now should hold the longest palindromic substring. Now let's look at the helper function expand around center. This function takes in the input string and the 2 pointers left and right representing the current boundaries of the expansion. For the odd length palindrome, initial value for left and right pointer is the same index. And for the even length palindrome, we pass in 2 consecutive index from the original string. Now we start the expansion process by running the while loop, where both the pointers expand outwards until both pointers remain within bounds. That is, left must be greater than or equal to 0 and right must be less than the length of the string. And if the pointers are within the bound, then the characters at those pointers must match. And if the two characters match, the expansion continues outwards by decrementing left and incrementing right. And once the while loop completes, either because pointers went out of bounds or characters didn't match, the left pointer will be one position before the actual start of the palindrome and right pointer will be one position after the actual end due to the last run of the while loop. Therefore, we need to extract and return the substring from left plus 1 to right minus 1 or up to right where right is exclusive, that is, it is not included. So in Java, we call the substring method from left plus 1 to right, and in Python, we slice the string from left plus 1 to right. And now the question is, can we do better? And the answer is yes. For that, you can look into Manacher's algorithm, which solves this problem in linear time. However, that is out of scope of this video. While it is a fascinating approach, it dives into specifics of the problem solving, whereas we aim to keep things generalized here. You can find a link to explore Manacher's algorithm in the video description. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.